Atlas III enters the heliosphere from the dark between stars with a motion that feels older than maps. It travels not as a wanderer tossed by chance, but as a line that seems already chosen, a slow arc traced across a wide and steady page. The frontier where solar wind meets the interstellar medium lies ahead like a quiet shoreline. Their charged particles' thin magnetic fields bend, and the first faint consequence of a new arrival moves through instruments that favor patience over spectacle. The sun does not greet it with drama, only with a widening awareness that something cold and small is joining the family of brightness for a brief and measured passage. On clear nights, the surveys keep vigil. The pattern of stars slides gently with Earth's turn and the steady pacing of planets. Against that tapestry, a single speck displaces itself just enough between exposures to betray a path that does not belong to the bound citizens of the sun. Astrometry gathers its points one calm epoch at a time, and the positions travel to the minor planet center where the provisional solution grows into a dependable track. The numbers sketch a hyperbolic course that bears the signature of an origin beyond the sun's hold. The uncertainty bars begin wide and then narrow not by argument but by quiet repetition. A corridor through space takes on width and depth. The International Asteroid Warning Network reviews the same postings with a different rhythm, cross-checking clocks and plate scales, and the small details that turn dots into a story. Each new night's work sharpens a line that was already straight. The inclination to the ecliptic lies at an angle that is modest rather than theatrical. The brightness refuses drama. Light rises and falls with a softness that suggests a body turning evenly. Many interstellar visitors tumble like loose collections of rock and ice. This one rotates with the unhurried steadiness of something that carries its balance comfortably, as if long practice has smoothed its motion. From far away, the object is only a nucleus wrapped in a faint breath of dust. It returns sunlight rather than heat. Photons scatter along grains ground fine by time, and a tail is more suggestion than structure. In these first weeks, the coma looks uneven, the kind of asymmetry expected at great distance and low temperature. What draws attention is the way that unevenness holds from night to night, as if the brighter side remembers where to be. Reports remain careful. Words like tentative, provisional, and consistent appear with regularity. The discipline is to notice, without naming, to let patterns speak before interpretation arrives. The Planetary Defense Coordination Office studies the same ephemerides with its customary prudence. The track clears Earth by a graceful margin, and that certainty grants room for curiosity. With risks set aside, attention leans into detail. The European Southern Observatory turns its mirrors on evenings when the air is steady and the glare of the moon is absent. Spectra come back pale but clean. Simple gases appear where they should. Dust bands whisper of ordinary silicates. Nothing leaps out of the graph to demand a new idea. The quiet finding is itself a kind of welcome, a visitor that fits the shelves already built for visiting things. As the weeks pass, the sun's influence grows. The bow of solar wind begins to press. The charge environment stiffens. The outer fringe of the heliosphere is more model than line, but the change is real in the behavior of particles and fields. Through that changing background, the object holds its path with guidance from gravity and light alone. Any non-gravitational effects hide beneath the noise floor of early measurement. Even so, the fit to a simple model remains pleasing, and planners mark calendars for moments when the geometry will improve, when angles will steepen, and when faint features might yield their shape. Astronomy makes a home in the ordinary and lets the unusual reveal itself at its own pace. Catalogs exist to prove that pattern comes first and puzzle second. Atlas III honors that custom. Its magnitude brightens at the rate expected of a dark surface growing warmer but not hot. Color indices sit near families already known. The rough estimate of size occupies the comfortable middle between small and large. Yet when many nights are folded together, a soft regularity appears in the light curve, a rhythm that resists the random. It is not dramatic enough to name, only steady enough to remember. That is how attention deepens, not with shock, but with a feeling that something is holding itself just a little too still. There are only a few ways to explain order at such distance. Geometry can make a pattern, and surface can lend a sheen. A working picture takes shape that is conservative by design, a modestly elongated body with patches that scatter light more efficiently than their neighbors. Ice rock and carbon can produce faces that seem deliberate when reduced to points and slopes. The picture does not require marvel to be credible. Even so, the steadiness invites longer exposures and kinder schedules. Instruments breathe slower. Timing grows regular. The community moves from discovery to companionship, the kind of sustained watching that lets small differences accumulate into meaning. The Solar and Heliospheric Observatory resumes its measured watching of the inner sky, and among the quiet entries on lists of interest sits the new arrival. That observatory keeps time in a way that ignores hurry, placing one observation after another until a life of measurements becomes a story. Before the object draws near enough to matter to a solar instrument, it lives there as predictions alone. Those predictions thread the bright geometry of the inner system with care. Redundancy is arranged, cadence is set. The assumption is that ordinary behavior will be recorded in ordinary frames and that this in its way will be enough. Meanwhile, the view from Earth answers to the small hands of weather and geometry. Nights slip by in both hemispheres. Clouds negotiate with ambition and observers take what the sky allows. Between interruptions, the positions are taken again and again, and the scatter in those positions falls away. The corridor grows narrower, the confidence grows wider, and the phrase most often typed into notes is on schedule. Where it came from remains a question left open on purpose. Possibilities bloom outward toward constellations with old names. The notion of origin settles on a simple truth: interstellar space is large enough to make direction a beginning rather than a conclusion. Names help memory take hold. Atlas III receives such a name because communities need handles for delicate things. The label does not claim meaning beyond sequence. It simply marks a member in a small lineage of interstellar travelers watched with modern eyes. If something unexpected waits ahead, the name will carry it without strain. If nothing unexpected appears, the name will hold a careful case study in how closely a small, cold body can be followed from the outer breath of a star to the place where heat begins to matter. Either outcome is a kind of answer. For now, the instruments keep their voices even. The path is true, the light is steady, the schedule is set. The sky holds more stories than a single object can tell, but this one begins with the comfort of things behaving. The deeper wonder that sometimes waits behind order is not yet invited. It will arrive if it does in its own time. In the present tense of watching Atlas III is simply here entering the region where the sun's voice grows louder, where dust learns to shimmer, and where attention finds its focus by listening to what is ordinary long enough for the ordinary to turn gently toward mystery. The first nights belong to measurement. Atlas III rides a path so slight that the difference between one pinprick of light and the next is a handful of arc seconds, but the sky is patient, and patience becomes method. Observers on high plateaus and island summits pass the target from west to east as Earth turns, handing the point of light from one clear dome to another. Each team sets exposure times long enough to lift the visitor above the background and short enough to prevent the image from dragging into a streak. The cadence feels like breathing. Open, integrate, close, write, repeat. Between frames, clocks sync to coordinated universal time mark the heartbeat that will later hold all nights together as one continuous line. Astrometry is a craft of small certainties. Pixel scales are tested against star fields whose positions are known to exquisite precision from the star catalogs built by space observatories that specialize in stillness. Atmospheric refraction is modeled and removed. The tilt of every instrument is measured against the sky. Thermal flex in metal and glass is considered, then quietly corrected. When the anonymous dot that is Atlas III is measured against these steady anchors, the difference between where it was and where it is becomes more than motion. It becomes evidence. The first solutions appear on the servers of the Minor Planet Center as a string of positions with residuals that fall well within comfort. The trajectory solver offers a hyperbola and assigns uncertainties that begin as generous envelopes and then shrink night by night. A preliminary rotation period hides in the flicker of the light curve. Photometry from small telescopes, when stacked carefully and cross-calibrated, shows a low amplitude undulation that repeats on a time scale of hours rather than minutes. The exact length remains a moving target, but the shape holds remarkably steady as viewing geometry shifts. It is the kind of regularity that suggests a body either close to spheroidal or turning, with its long and short faces so gently presented that no harsh variation breaks the line. No deep bursts of brightness betray a broad, flat facet swinging past the sun. No ragged shadows announce a jagged outline. The curve leans toward order. Color indices measured through filters that separate blue from red and near infrared settle into values that match dark carbon-rich surfaces dusted with fine grains. The spectrum at these distances is modest and clean, a whisper of simple ices, a murmur of silicate dust. The European Southern Observatory adds a longer look when conditions allow, letting the signal build quietly on a stable detector until weak absorption features relax into view. Nothing insists on novelty, the comfort of familiarity holds, yet inside that familiarity is a thread that draws attention, the slight phase lock modulation that repeats even as the phase angle changes. It is faint, but it is faithful. Coordinators at the Planetary Defense Coordination Office treat all interstellar visitors with a practiced balance of caution and curiosity. The early solution places the object's future close approach well outside any region of concern, and that clearance frees time to schedule deeper looks. The International Asteroid Warning Network circulates an observing plan that staggers longitudes and latitudes so that gaps are few and the object is never lost to an inattentive sky. The plan reads like choreography, set to a very slow song. A mountain in Chile takes the opening measures. A ridge in the Canary Islands lifts the next phrase. A desert in Arizona carries the line into the night that follows. Noise lives everywhere in astronomy. It hides in electronics, in the trembling of air, and the faint breath of frost on a lens. The first nights push that noise down by repetition. Dither patterns move the image across different parts of each detector to average out the personalities of pixels. Bias frames and dark frames subtract the signatures of the instruments themselves. Flat fields tame the uneven response of glass and mirror. What remains after this quiet housekeeping is the thing itself, a small body turning in sunlight that grows stronger with each day closer to the inner system. The Solar and Heliospheric Observatory cannot yet see the visitor, but it already carries the future of the record. Its cadence of 12 seconds promises a rhythm that, when multiplied by hours, will draw a fine-grained movie of approach and departure, for the moment ground-based data lead. The light curve gathered from Earth hints at a rotation that neither hurries nor stumbles. The absence of large amplitude suggests a shape shy of extreme elongation. A working model takes form, a nucleus a few hundred meters across, perhaps larger, wrapped in a coma that is presently thin, with outgassing so gentle that no asymmetric thrust is visible above the measurement floor. In the background, software trained on comets and asteroids runs simulations by the thousands. It varies the spin axis, the elongation, the reflectivity of imagined patches, the porosity of imagined crusts. The goal is not certainty, only plausibility. Many combinations can reproduce a small regular light curve. The notable finding is not that a solution exists, but that a family of solutions exists in which the rotation remains steady across weeks without forcing extreme assumptions. Stability can be natural. A body compact and slightly rounded can roll through sunlight like a polished stone across a shallow stream. The first nights also set the tone for cooperation. Amateur observers contribute calibrated measurements from modest apertures that, when folded into the professional sets, fill gaps with care. Space agencies publish gentle notices that do not raise alarms and do not bury interest. The Hubble Space Telescope schedules a contingent slot for later when the geometry will be kinder. The European Space Agency prepares the solar orbiter's planning for chance alignment. The Parker Solar Probes teams note the dates when orbital positions might allow an incidental crossing of the visitor's downstream environment. Each group moves at its own pace, yet each seems to hear the same quiet guidance. Watch closely, say only what the data say, let the rhythm reveal itself. Through all of this, Atlas III behaves. Its magnitude follows the soft brightening expected from a dark surface nearing warmth. Its positional residuals, when plotted, make a cloud so tight that the line drawn through them feels less like a guess and more like a trace. The phrase non-gravitational acceleration appears in early drafts of notes, only to be put aside for later. If it comes, it will come honestly as a departure that survives scrutiny rather than a hope that seeks pattern too soon. The quiet discipline is to let prediction lead and then confirm or adjust with small hands. As dawn glows on the last of these first nights, the story held by the curve and the positions is simple and sufficient. A visitor from beyond the sun's hold is turning, calmly reflecting light with a steadiness that suggests balance, moving through coordinates that tighten their confidence with every shared hour of watching. Wonder attends without insistence. The sky gives what it gives. The instruments accept without forcing a meaning. The curve has a pulse. The path keeps time. The next steps will carry the object into glare where solar instruments take over, and where the quiet regularity of now will be tested against heat and brightness. For the moment, the first chapter closes on order, which is its own kind of mystery. Conjunction arrives like a curtain that moves at the pace of orbits. The object drifts toward the line between Earth and Sun, where glare is not simply brightness but geometry, a layout that asks even the best instruments to wait. Predictions guide eyes more than photons do. The corridor of uncertainty has narrowed through weeks of careful work, and the final ephemerides reach observatories with confidence expressed in quiet tables and patient maps. The plan is simple in outline and intricate in sequence. Ground telescopes carry the story until the sky grows too bright. Then solar spacecraft take the line through the glare and pass it back to night once the sun loosens its hold. The handoff depends on time kept clean. Clocks aboard the solar and heliospheric observatory keep step with stations on Earth. The solar orbiter and the Parker solar probe hold steady metronomes of their own. Each platform knows where it points and when it records, and each one schedules cadence to overlap the others so that loss in one record can be cushioned by presence in another. That choreography is the earned habit of many years, a quiet discipline shaped by the ordinary desire to keep a story unbroken even when the storyteller must look straight past the sun. As the object nears the star, the inner instruments begin to tease it from the wash. Coronagraphs subtract the disk, revealing the haze just beyond. Difference images peel away the constant, leaving change behind. The visitor enters those frames as a pale seed of motion, first barely more than noise, then confirmed across successive exposures that keep careful time. Ground-based teams continue to measure until the air itself becomes a veil too thick. When the last night yields its final points, the residuals still curl around zero like a contented cat. The line on the sky looks true. During conjunction, the work shifts from seeing to projecting. Analysts propagate the orbit forward hour by hour, tallying the tiny forces that might bend a path by less than the width of a hair across the field. Solar radiation pressure is added a push so gentle that it matters only because time is long and distance is great. The possibility of small jets is held in reserve, a parameter left at zero until new data earn the right to change it. The shared expectation remains quiet, a clean in, a clean out, perhaps a small seasonal brightening, and then the comfort of reappearance tucked back into night. While the sun fills the center of view, the rest of the network listens. Radio arrays glance across the region for hints of ionized tails. Particle instruments aboard the solar missions note the background as a baseline for later. Nothing in these side channels waves for attention. The space near the star behaves as it often does, alive and complex, but within bounds that the forecasts know. The visitor becomes a small part of a larger weather, another leaf moving through a windy square. The day of reappearance comes with the same lack of theater. The sky does not announce it, software does. An algorithm flags a dot that has shifted just enough between two frames from a southern observatory to merit a second look. The second look agrees. A third frame secures the motion, and a message flows quietly through the coordination lists. The object is back in reach of night, its brightness near the value expected for the new phase angle. The reacquisition feels like a return from travel exactly on time. Then differences begin to accumulate almost politely. When the fresh points are folded into the orbit solution, the line that best fits the entire story asks to tilt by a margin small enough to miss if attention is hurried, yet large enough to persist when nights begin to stack. The new arc sits a little beside the old one. The change is measured in a few arc seconds on the sky, which is to say tiny to the eye and meaningful to the equation. Uncertainties are rechecked, reference stars are verified. Plate scales and timing are reviewed against catalogs and against the heartbeat of coordinated universal time. The offset remains. The thought that rises first is ordinary, perhaps radiation pressure pressed a little more than assumed, perhaps the shape is broader than the initial models allowed, giving sunlight more sail to push against, perhaps a vent lit briefly inside the glare and gave a nudge too faint to scatter dust but strong enough to lean the track. All of these are natural and comfortable ideas, and none of them require invention. The work now is to choose among them with the same patience that made the early corridor narrow. Across the next evenings the pattern holds. Independent observatories at different longitudes and latitudes confirm the same small displacement. The brightness curve continues its unhurried pulse, the rotation period settling by fractions toward a fixed value. No dramatic plume appears, no flare of dust that would mark a fragment. The coma looks tidier than before, not larger. If jets are present, they hide beneath the resolution of instruments that can see from this distance. The offset remains a quiet note that sounds the same in every ear that listens. The Minor Planet Center posts an updated solution with a note that the non-gravitational terms have been allowed to float. The terms settle at values that are not large but are not zero. In the language of this trade, that is enough to say that sunlight or some other gentle process has added its hand to the steering. The International Asteroid Warning Network records the change and relays the revised corridor to those who will need it later for planning. The phrase used in summaries is modest, a small systematic deviation stable across nights. What makes the moment interesting is not size but coherence. The offset does not wander. It points in nearly the same direction from night to night, as if aligned with some durable feature of the body or the light that bathes it. There is a sense, still slight, that the object's response to the sun is more organized than the rough sputter expected when ice turns to gas in a hurry. That sense stays unspoken in public notes, expressed instead as a preference for models in which thrust, if present, is steady rather than impulsive, and in which radiation pressure meets a surface that presents itself neatly to the light. Reappearance is also a check on memory. Teams compare the last frames before the object entered glare with the first frames after it leaves. The light before was a touch more ragged, the coma a touch uneven. The light after looks smoother, as though something that was loose has settled. A surface that was patchy now seems to reflect more evenly. The interpretation is left open. Heat can burn away irregular frost and leave a plainer face. Time near the star can erase the small textures that once caught photons like burrs. By the end of the first week back in the dark, the orbit is again a line that predictions can ride with ease. The adjustment is written into the tables, and the schedule of deeper looks resumes with only minor edits. If a nudge occurred, it was small. If the sun's pressure performed the work alone, it did so with a steadiness that hints at symmetry. The reappearance gives back the comfort of forecast while keeping a ribbon of curiosity intact. The story continues forward under the same rule that has guided it from the beginning state. What the instruments show, let patterns speak first, and allow mystery to enter only as softly as the data invites. The missing frame begins as a footnote that does not intend to carry weight. The Solar and Heliospheric Observatory keeps a steady cadence measured in a dozen seconds, and redundancy with the Solar Orbiter and the Parker Solar Probe is arranged so that no single gap should matter. Yet, during the moment of closest approach, the record that should have been ordinary fails in the same way across independent systems. A blank interval takes the place of light and motion, not torn by noise and not filled by static. It is simply empty, a clean absence where a bright instant ought to live. The duration is modest and memorable, a little more than 38 seconds by careful reconstructions precise enough that clocks on different platforms agree within their small tolerances. The timestamp sits almost exactly at perihelion, the point where geometry and heat both reach their quiet extremes. The cadence before and after remains healthy. Instruments do not stumble. Telemetry does not panic. Streams that should carry an ordinary rise and fall of scattered sunlight flow as expected, and then the interval arrives, and then it ends, and the story resumes as though nothing unusual has happened at all. Ordinary explanations step forward first, because most puzzles dissolve under simple causes. The sun can flood sensors with brightness that surpasses design. Compression can discard frames that exceed range. A cosmic ray can strike silicon with a brief decisive tap that topples logic for the span of a heartbeat. Packet loss can empty a line even while hardware feels well. Each instrument has suffered these fates before, and archives prove that such mishaps are not rare. If one platform alone had faltered, experience would have closed the question. But this absence repeats across clocks that are not supposed to fail together. Checks run quietly behind the scenes. Magnetometers review their tracks for the crest of a solar shock. There is no spike. Solar wind monitors report background that changes only within ordinary weather. The visible disk does not tear or brighten in a way that would explain a coordinated oversaturation. Bulletins remain plain. Conditions near the star are lively but not unusual. The absence does not carry a storm behind it. It is a silence without a shout. When visibility returns, the object stands a little aside from where prediction placed it. The difference is small enough to miss in a casual glance and large enough to persist when the new arc is fitted to the old. A trajectory that had promised to exit on one neat curve now tilts by a fraction of a degree. The fit improves if a gentle, steady hand is added to the model, the kind of non-gravitational term that approximates a constant push. In the language of comets, that hand is often sunlight on surface, a soft pressure, or a quiet jet that breathes without drama. Thermal expectations had favored quiet at the very moment of closest sweep. Volatiles should be too hot for orderly thrust at that proximity, and any eruption should be ragged rather than neat. The light curve changes character in a way that invites attention without insisting on spectacle. Before the gap, the coma wears a slight asymmetry that leans toward one flank. After the gap, the brightness looks more even, as if a rough coat has burned away to reveal a smoother face that reflects light with fewer seams. Reflectivity rises a little. Scatter grows cleaner. The picture shifts from dusk to surface. Engineers walk patiently through the simple failure modes because consistency across platforms can sometimes hide a shared assumption. They comb through compression thresholds, gain settings, time server handshakes, pointing models, and the logic that decides when a saturated frame is labeled bad and dropped. The results are unremarkable, which is their own kind of remark. No shared software change appears at the critical hour. No clock slip emerges to align the gaps by accident. The networks that keep time do not confess a stumble. The housekeeping remains dull as it should. A separate thread examines the frames at the edges of the whole. The final image before the pause shows a body a touch elongated, the way a rotating and somewhat irregular object can look when geometry favors its long face. The first image after the pause presents a form that appears more compact and a coma more symmetrical. The difference is subtle, the kind of change that would invite caution on any other night, and yet it repeats in independent reductions prepared by groups who do not share code. Shape, light, and position all lean in the same small direction. Radio observatories add a narrow note. In the minutes that include the gap, several antennas report a brief feature near 2 1/4 gigahertz lasting less than 2 seconds and faint enough to sit near the floor of confidence. The direction arrives close to the solar limb and the timing brushes the edge of the missing interval. Later, when orbits and pointing are reconciled, the vector does not match a known satellite, the feature does not repeat, and the entries remain labeled tentative, but the alignment is hard to ignore. A small sound near a small silence. Because the scene refuses a single clean answer, the community does what it does best, and lets parallel possibilities live side by side for a while. One path favors sunlight and surface, a mirror-like response developing briefly under heat that both brightens and pushes. Another path keeps a small, well-behaved vent alive in models, even where theory would ask it to fail, letting a steady plume nudge the orbit while hiding its texture in the glare. A third path, more tentative, leaves room for a transient interference, a narrow band veil that momentarily closes the view without leaving the signature of a storm. None of this conversation changes the object itself. It remains small, dark, and disciplined. The rotation stays steady. The brightness holds its pulse. The coma does not explode into fragments. The path across the sky is again a line that predictions can ride with ease once the quiet push is acknowledged. The missing frame therefore ceases to be an absence and becomes a place. It is a coordinate defined by clocks rather than by distance, a point to which analysts return when new evidence needs an origin, the way a map returns to a marker at the bend of a river. In that sense, the gap behaves like a landmark drawn on a sea that has no fixed shores. Later chapters will chart changes in thermal bands, in polarization, in chemistry, and in the way dust and gas trace the field through which the visitor moves. Each of those changes will look back to this moment to see whether something began when nothing was seen. For now, the sun remains quiet in the record. The instruments remain healthy, the visitor moves on cool and obedient to mathematics, leaving behind a neat line of coordinates and a small bright question that waits without impatience. Heat arrives at closest approach like a tide pressed thin. Atlas III crosses a contour where sunlight does more than brighten a surface. It tests the structure of whatever lies a few millimeters beneath. In most small bodies, the response is familiar. Ice turns to gas, gas drags dust, and brightness blooms in ragged patches that swell and fade. The record for this passage writes a different line. Instruments that watch the inner sky register a brief sharp surge that rises quickly and falls with unusual neatness, a single clean hill where a range of uneven peaks would normally stand. The Parker Solar Probe carries particle and field sensors that keep steady company with the sun's wind. In the minutes around perihelion, those sensors add a quiet footnote to the log. A narrow rise in infrared energy appears from the direction of the object, short in duration and tidy in shape. The curve resembles a mirror catching light rather than a furnace shedding heat. The solar orbiter, with its spectrometer tuned to tease chemistry from glow, notes a banded pattern in the thermal signal that does not scatter across the whole surface. Instead, it gathers in a belt, brightens together, and then disappears as one. Ground-based observatories working in near-infrared confirm a pulse that lasts less than 2 minutes. They do not see a storm, they see a flash that respects its own edges. The coma does not balloon in response, it contracts. The light becomes more compact as the spike fades, not less, and the color shifts toward a cleaner, cooler reflectivity that reads less like dust and more like exposed skin. The expected plume of vapor is absent at the scale of these instruments. If gas escapes, it does so with an order that resists easy notice. The most conservative language holds first place by custom. Some of the rise can be attributed to geometry, a favorable angle that amplifies the brief contribution of specular reflection, the way a smooth patch can momentarily collect sunlight and return it in a narrow beam. Some of the neatness can be explained by a surface that sheds its most fragile coat in one swift passage, leaving behind material less eager to crumble. Nothing in that picture requires new physics. It does, however, ask a surface to behave with unusual composure in a region where agitation is the rule. Cooling follows faster than models expect for a face that has been driven hard. Thermal inertia, the stubbornness with which heat lingers, should slow the descent. Instead, the curve falls as if guided. There are two ordinary ways to draw such a line. One is to reduce absorption in the first place so that sunlight has less to deposit. A newly smoother crust can do that by reflecting more efficiently. The other is to move heat laterally and radiate it from a broader area than the spike first suggests. A belt that brightens and then dims together implies such sharing a brief cooperation across longitudes before quiet returns. Spectral hints align with the change in finish. Before perihelion, the light carries the signature of fine dust suspended above a darker base. Afterward, the dust weakens and the base looks cleaner. The fraction of light that returns in a mirror-like way grows. The polarization of scattered light leans toward values associated with smoother, more layered materials. Again, none of this demands invention. Flash heating can sinter a thin crust welding grains into a more continuous sheet. Sublimation can strip away frosts that once roughened the face. Small bodies often build and erase such skins as they pass through warmth and cold. What matters here is how quickly the transition completes and how calmly the aftermath holds. Timing ties the thermal event to the earlier absence like two beads on the same thread. The spike rises within the window set by the missing frames, and the more even face appears in the first images after the pause. The orbit solution improves when a small, steady push is allowed to act through this interval. A surface that becomes more mirror-like at just the moment when geometry favors a brief flash could in principle both brighten the record and add a gentle pressure in one direction. Radiation pressure is soft, but near the sun, even softness can steer if the sail is smooth and oriented well. Models built for dust-rich comey struggle to reproduce the neatness of the curve. They tend to spray and smear. Models that allow a transient change in surface properties fare better. A thin layer of volatile material can vanish quickly under concentrated heat, leaving behind a harder, darker substrate that reflects more efficiently and absorbs less. In laboratory terms, it is a phase change of texture, rather than composition, a rearrangement of how small facets collect and return light. The sky writes such transitions in brightness rather than in micrographs, and brightness here insists on a story with fewer moving parts than a burst of gas. A quieter possibility opens alongside these simple pictures. If heat rearranged not only grains, but also the way charges move near the surface, the skin could briefly become better at managing energy, not merely reflecting it. Photons could be encouraged to leave rather than linger, and that preference would show up as cooling that outruns expectation without demanding extra radiation elsewhere. Such language borrows from the behavior of thin films and layered coatings tested under artificial suns. It remains only a metaphor in this setting, a way to say that the surface after the spike behaves more like a single piece and less like a loose assembly. The absence of turbulence in the surrounding space is as notable as the shape of the spike. Plasma instruments that would sing in the presence of a violent outburst stay near their background. Dust counters do not register a rain. The belt brightens and fades, the coma tightens, and the environment remains composed. If anything, the calm sharpens the lines drawn by the heat. Energy arrives, organizes itself briefly along an equator, and then declines without scattering the neighborhood. The scene reads as conduct rather than eruption. What remains uncertain is whether the belt marks a structural feature, such as an equatorial ridge that naturally catches and shares heat, or a transient zone defined by rotation and sunlight where day and night trade places in a way that concentrates stress. The light curve's steady pulse supports both, since an equator laid near the plane, favored by our view, would cue the same repeating emphasis whether the belt is built or temporary. Later sections will look for signatures that distinguish between a fixed band and a traveling one. For now, the belt serves as a quiet proof that heating was not uniform and that its retreat was cooperative. Perihelion is a test that many small bodies pass with noise. Atlas III passes with poise. The spike is real, the belt is real, the cooling is quick, and the light that follows is cleaner than the light that came before. Those are the pieces that instruments agree upon across platforms and perspectives. Explanations live in the tidy space between reflection and release, between a crust that grows smoother and a surface that learns briefly to guide heat rather than simply endure it. The next frames will ask whether that poise extends into motion, whether a line of heat can lead to a line of action, and whether the same calm that shaped a flash can also shape a gentle change in path. The line appears first as a brightness thread drawn cleanly from the sunward face and held straighter than the haze around it. In post-perihelion frames, the coma tightens as earlier sections described, and within that leaner light a plume emerges that resists the usual fanning of dust. Instruments aboard the solar orbiter and ground-based arrays that work in narrow bands record the feature as a column that keeps its axis nearly aligned with the anti-solar direction even while the body turns. Rotation usually sweeps a jet like a brush, bending it into a curve that sketches the spin. This one holds still against the turning, as if geometry and flow find a mutual agreement that outlasts the brief warmth. Brightness profiles along the length of the plume tell a soft story of cohesion. Instead of dimming quickly with distance from the source, the intensity lingers, tapering slowly as though the material is guided rather than allowed to disperse at once. The shape is narrow, near the origin, and does not bloom into the broad cone that simple gas expansion would sketch. Polarimetric measurements find the light scattered by the plume more organized than the surrounding coma, with a signature that leans toward finer particles or ionized material that prefers a direction. The impression, carefully phrased, is collimation, a flow that keeps itself gathered. The timing links the plume to the heat event. The first clear appearance follows the brief thermal spike by only a small interval, as though one was a preface and the other a response. The belt that brightened at perihelion lies near the latitude where the plume anchors. That connection invites models in which the spike could have cleaned a path or prepared a vent. A deep fracture would concentrate gas and dust into a single exit that keeps its aim while the nucleus turns beneath it. A narrow shaft could serve as a natural nozzle, neither design nor accidental, but the end of stress lines guided by composition and temperature. From a distance, the difference between a well-shaped fracture and a self-maintaining jet is mostly a matter of persistence. The plume persists. Observatories separated by oceans and by orbits collect sequences that show the feature holding alignment across spans, measured in several minutes, sometimes longer, and then ceasing abruptly rather than fading. The cutoff looks less like exhaustion and more like a switch that finds its end. In the next frames, the coma returns to its compact equilibrium, the line gone as if it had never been there. The rise, the hold, and the stop are all tidy. Plasma instruments add a quiet supporting note. Faint fluctuations in local fields brush the background during the intervals when the plume is strongest. They are not large enough to announce a discharge and not irregular enough to read as turbulence. They look like a small signature of organized material meeting the solar environment and choosing a path through it rather than scattering. If the plume carries a fraction of ionized particles, the prevailing field would help keep the column narrow, drawing a shape that reflects both origin and medium. That picture belongs to the conservative shelf gas becomes ions under heat, and light ions follow a lane marked by field lines, and the result is a plume that seems steadier than a cloud of dust pushed only by expansion. The motion of the body reacts in proportion to the modesty of the plume. Orbit solvers find that the best fit improves again when a small constant push is applied for the minutes when the jet is present. The direction of that modeled push is nearly opposite the plume's axis in the way that thrust often balances an exhaust. Described plainly, the change in the path is slight, but it repeats the same orientation that the non-gravitational terms had begun to prefer after reappearance. A flow that stays straight for long enough can add a tiny correction to velocity without leaving a visible storm behind it. The outcome reads as a nudge, not a shove. The Parker Solar Probe's particle counters pass downstream of the projected line and register no rain of heavy dust. That absence argues against a burst that would break and scatter the surface. Instead, the column seems to consist of fine material and gas moving in an orderly way. The solar orbiter's spectrometer in the same window finds hints of metallic species mingled with simple volatiles, echoes of the chemistry discussed earlier in which heat and composition exchange roles. The presence is faint and respectful of background, but it fits the impression of a flow that has been filtered by a path through deeper layers rather than a broad erosion of the outer skin. Comparisons to typical cometary behavior help frame the difference without exaggeration. Many comets display jets that flicker and sweep, braided by rotation and uneven pressure, their boundaries mottled by small turbulence. When those are averaged over time, the curves soften into fans. Atlas III offers for a limited interval a line that declines to be averaged. Its steadiness is not total. Small ripples ride the column as the view geometry changes, and the light along the shaft lives as a gradient, not a plateau. Yet the whole holds its aim with a restraint that asks for explanations with fewer moving sources and more cooperative guidance. One set of models places the cause in the object alone. A deep channel opens, perhaps enlarged by the perihelion belt's brief heat, and a pocket of gas uses that path until the reservoir is spent, or a rotating wall shadows the entrance. In this picture, the alignment of the plume with the anti-solar direction is a coincidence of geometry. The channel happens to point away from the sun for a few minutes of a turn, and the observer's line of sight projects a straightness that in 3 dimensions would trace a narrow arc. This is a comforting account because it does not need a new actor, only a well-placed crack. Another set of models allows the environment to share agency. If the flow emerges already fine-grained and the solar field nearby is quiet, the ions within that flow can be shepherded into a column that takes its cue from the larger structures around it. In that case, the direction is not an accident, but a consequence of where the body sits within the wind. The plume's steadiness reflects not only the behavior of the vent, but also the steadiness of the field and the pressure at that hour. The abrupt end then becomes the moment when supply and guidance fall out of phase, and the column can no longer be sustained. A third model belongs to the same shelf as earlier speculations about surface order. If the perihelion spike altered the top layer so that patches can manage energy more coherently, then evaporation itself could proceed with an unusual discipline, favoring one clean outlet until local feedback tips the balance and turns the process off. This remains only a way to say that the plume's neatness may be related to the belt's neatness without claiming more than parallel conduct. The record does not support invention beyond that. It supports the continued observation that in the minutes after the heat event, motion follows lines rather than clouds. By the end of the interval in which the straight jet appears, the wider scene remains calm. The brightness curve keeps its modest pulse. The coma, once the column ceases, settles quickly back into symmetry. The updated orbit now, with its small correction, acknowledged once again, forecasts positions with comfort. The line drawn by the plume therefore becomes another landmark in the growing map of feature as discrete as the missing frame and the thermal hill, a sign that the passage through perihelion is not only about endurance, but also about brief measured action. Whether that action is a vent in a fortunate place or a flow guided by an environment that happened to be kind, the effect on the path is the same, a gentle touch, straight enough to be noticed, brief enough to be missed, recorded, because many eyes were watching the same thread at the same time. Light does more than brighten. It keeps a memory of how it touched a surface. After perihelion, that memory changes in a way that instruments register with unusual unanimity. Polarimeters on mountain summits and aboard spacecraft measure the orientation of the electric field in scattered sunlight and find that the preferred orientation has flipped sign across several bands. Before the close pass, the light scatters in the way dust usually does, with a polarization that follows the familiar positive curve for a rough, fluffy coma. Afterward, the same measurements lean negative and hold that sign across a range of phase angles where comets rarely sustain it. The inversion is not dramatic to the eye, but in the arithmetic of polarization, it is decisive. The first detections arrive from observatories known for careful work in this narrow art. A solar polarimeter in Japan publishes a provisional sequence. A European Southern Observatory team repeats the measurement under different sky and different air. A third group on a high ridge in the Canary Islands confirms the trend. Each reports the same quiet turning of the curve and the same soft increase in the fraction of light that behaves as if it has left a smoother skin. Instruments aboard the solar orbiter see the change persist near the limb, where glare complicates everything, and yet even there the sign remains. Calibration frames taken against standard stars and well-understood fields hold steady. The flip is not a trick of glass or software. Polarization depends on geometry as well as surface. A small body can create a negative branch at very small phase angles simply because of the way light plays through fine grains. Those behaviors are catalogued expected and ordinary. What is uncommon in this case is the breadth and steadiness of the inversion across hours when the phase angle is changing and across wavelengths that do not usually agree so tightly. The curve that once rose and fell now sits below zero like a shallow lake, almost level with only a faint ripple that matches the rotation period already measured in the light curve. It is as if the surface has grown more uniform and more directional at once. Spectral polarization adds nuance to the change. In bands where dust grains typically dominate scattering, the inverted sign persists, while in bands sensitive to very small particles, the signal weakens as though the finest haze has been reduced. That pattern matches the earlier finding that the coma tightens after the thermal event. Less loose dust means less random scattering and a cleaner path for light to reflect from surfaces with coherence. Coherence here does not imply a mirror-polished plane. It suggests many small facets acting together so that the emerging light carries a shared orientation. A family of explanations lives on the conservative shelf. The perihelion spike can sinter a thin crust, melting and rejoining microns of material into a tighter skin that reflects with fewer random tilts. That shift alone can drive polarization negative at the angles sampled, particularly if subsurface layers provide a faint second reflection through pores that act like a low-grade waveguide. Another explanation looks to coherent backscatter, a known effect in which light that threads through disordered layers finds a preferred route back along its incoming path, enhancing certain orientations. Both pictures rely on texture and layering, not on composition, and both are consistent with a face that has grown more uniform in the minutes after heat. The persistence of the inversion with rotation invites a map. Observers fold polarization against the period established by photometry and find a pattern that repeats with small, smooth undulations. Peaks and hollows align with the same longitudes that mark the slight rises in brightness, as if zones that reflect a little more also organize light a little better. The amplitude is modest. Nothing sharpens into a flash. Instead, the signal describes a body that has not become a single plate, but that presents alternating panels that share a finish. The word panel remains metaphor. The data only insist that parts of the surface now behave alike. The environment near the sun can complicate any reading. Scattered light glare and the play of dust in strong fields have fooled instruments before. For that reason, tests multiply. A careful subtraction of sky polarization is performed at each site. Instruments rotate their own optics to confirm that the orientation of the detected signal belongs to the target and not to the bench. Independent pipelines reduce the same frames and return the same sign. If a bias from the star were at work, it would not hold the same direction across longitudes and long nights. The persistence argues for the target. In parallel teams, revisit the pre-perihelion record to measure just how much had to change. Before the spike, the curve shows the gentle positive slope common to dusty Como. The magnitude matches a surface that is darker and rougher, covered by a breadth of grains that scatter light in many random planes. After the spike, the curve flattens and turns, implying that a smoother layer now occupies the scale that light interacts with. That scale is small thickness measured in hairs of a millimeter, and below where heat can travel quickly and rework textures without moving bulk. The nucleus need not have changed its shape to alter its light. A separate line of evidence nods in agreement. The degree of polarization varies slightly with the viewing wavelength in a way that hints at thin film stacks of layers whose thicknesses differ by small consistent amounts. In laboratories, such stacks create interference colors and polarization features. In space, few places assemble them naturally with order. Here the features are faint and safe to describe as suggestive rather than declarative. They add flavor to the more robust fact that the light now prefers an orientation that rough dust alone would not sustain at these angles. Putting these threads together yields a picture in which the perihelion belt did more than shine. It reworked the surface into a smoother stratified skin that reflects light with a shared direction. The plausibility of such a skin grows when the chemistry and heat already discussed are remembered. A brief period of intense illumination can drive off frosts, collapse pores, and fuse grains along a line of latitude, leaving a shin that behaves less like a pile of grit and more like a coherent sheet. When the body turns, the sheet carries its new habit through day and night, and the polarimeters record that habit as a calm inversion that drifts only gently with longitude. Motion and light speak to each other in this setting. A surface that reflects more directionally also feels radiation pressure differently. The gentle, steady, non-gravitational terms found in the orbit solution after reappearance sit comfortably beside a skin that angles sunlight rather than swallowing it. The straight jet, when present, may have shared the same guidance. An outlet made cleaner by heat could have ejected a narrow stream that inherited some of the surface's order. The record does not force this linkage, but it allows it. And the harmony between polarization, brightness, and motion keeps the narrative of measured order intact. What the inverted sign does not say is as important as what it does. It does not require an artificial finish, only a newly disciplined one. It does not assert composition beyond what spectra already grant. It does, however, mark a threshold where the object stops behaving like a cloud with a stone inside and starts behaving more like a single piece that has learned briefly to keep its face. The inversion therefore stands beside the missing frame, the thermal belt, and the straight plume, as another landmark added without haste, a small turn in how light remembers the surface, sustained long enough and broadly enough to suggest that heat and rotation together have organized the outermost layer into something smoother layered and gently directive. The next measurements follow that hint inward from light to chemistry to see whether molecules have rearranged themselves with the same restraint that photons now reveal. Chemistry answers softly at first, then insists. Spectra collected before perihelion had painted a familiar blend bands where water ice and carbon dioxide should whisper shoulders, where carbon monoxide rises. When heat begins to work its slow change, a dust continuum that behaves like dark minerals warmed at distance. After perihelion, the lines alter in a pattern that does not fit a simple story of venting. The signature that marks carbon dioxide fades instead of swelling. The band that belongs to carbon monoxide strengthens not explosively, but with a steadiness that matches the new calm seen in light and polarization. The change does not announce fragmentation, it resembles rebalancing. The infrared telescope facility on Mauna Kea reports the first clean hint of the shift when the object emerges from glare. Observers integrate patiently through the thin air, stacking minutes into signal until the small troughs that indicate gases speak above noise. The expected 4¼ micrometer carbon dioxide feature, strong in many comets at such geometry, sits lower than predicted by models parameterized with the pre-perihelion record. In the same frames, a narrower mark consistent with carbon monoxide brightens beyond forecast. The ratio turns upside down at just the moment when the earlier light suggested that the surface had shed a fragile coat. On another summit, the Subaru telescope repeats the measurement with longer exposures and confirms the direction of the change. In the southern desert, the Atacama Large Millimeter Array works at longer wavelengths and adds a cautious note: faint narrow features appear where metallic carbonyls would live if present, most notably the pattern that laboratory chemists recognize as nickel bound to carbon monoxide in a complex that forms and falls apart under moderate heat. The lines are weak and deserve conservative treatment, yet they recur over several nights and do so with a cadence that seems to lean toward the same period already noticed elsewhere, a period near 28 minutes from crest to crest. The European Southern Observatory brings another eye to the question and folds its spectra against the now settled rotation period. The modulation in the carbon monoxide line undulates gently with longitude, as if some sectors of the surface supply more than others, but none run wild. The carbon dioxide line refuses to follow, remaining below prediction across the full turn. A picture gathers in which carbon dioxide is not simply absent, it is being transformed into something that the instruments detect differently. Photodissociation under hard light could split carbon dioxide into carbon monoxide and oxygen, but the straightforward oxygen signatures that would then rise do not stand up in the record. If oxygen is set free, it does not remain free for long. The chemistry has a natural shelf to sit on even without invention. Surfaces rich in metal grains can host reactions when warmed with carbon monoxide, playing carrier and partner. The Mond process, known on Earth for refining nickel by forming a volatile nickel carbonyl that later decomposes to leave pure metal, offers an analogy rather than a claim. In space, the pressures are low, the exposures uneven, and the radiation complex. Yet the simple idea that moderate heat can encourage carbon monoxide to bind, carry, and unbind while moving energy fits the direction of the lines without insisting on machinery. It is enough for the narrative to note that the same element, nickel, does not surprise planetary scientists when found as traces in Comets, and that carbon monoxide is a common participant when volatiles begin to move. The timing lifts the chemistry out of the abstract. The largest difference between carbon dioxide and carbon monoxide appears in the hours just after the thermal belt's bright interval and the faint metallic carbonyl hints flutter in phase with the slow pulse that photometry and polarization already track. A system that warms along a latitude band, sheds its dusty shell, and then presents a smoother face to sunlight would also present a different microclimate to trapped volatiles and to the metals embedded within the topmost layers. The result could be a one-turn cycle in which carbon monoxide forms and falls away in breath-like timing, carrying heat from place to place before the new crust returns to calm. Analysts test more ordinary pictures in parallel. Could simple depletion explain the drop in carbon dioxide? Perhaps the reservoir nearest the surface was already scarce. Pre-perihelion lines argue against a barren skin, but small bodies are not uniform, and a thin, enriched patch can fool forecasts. Could geometry alone weaken the line phase and projection effects are calculated and subtracted? The deficit remains larger than such corrections can carry. Could dust opacity hide the band? The coma is thinner after perihelion, not thicker, and the continuum that would betray a heavy screen does not rise to smother the valleys where gases speak. The same housekeeping that keeps astrometry clean serves here. Check the catalogs, cross-calibrate instruments, subtract the sky, verify the lamps. The signal survives the habits of care. A quieter thread follows oxygen through the data in case the simple split of carbon dioxide has happened unseen. Atomic oxygen lines that often announce photodissociation and Comets fail to climb. Molecular oxygen is a rare prize even in generous comets and stays hidden here as well. If oxygen is born, it seems to bind again quickly, perhaps to dust, perhaps into fleeting oxides, perhaps into compounds too transient or too cold to declare themselves in these bands. The absence of a clean oxygen partner does not close the case. It simply strengthens the impression that the chemistry has chosen channels that are selective rather than explosive. The cadence in the metallic carbonyl hints invites caution, because periodicities can grow from instruments as readily as from targets. Teams rotate, gratings change slit angles, and process the same frames through independent pipelines to see whether the slow pulse is a ghost of procedure. The undulation remains small and patient, aligned with the rotation tracked by light. No one publishes the word cycle with confidence. Instead, they prefer modulation, a humbler noun that says only that something rises and falls in time with the spin. The amplitude is slight, it is the regularity that matters. All of this can remain comfortably natural. Heat lifts shallow layers. Carbon dioxide within those layers reacts or departs while carbon monoxide lingers more stable under the new conditions. Traces of nickel and other metals act as reluctant hosts for carbon monoxide complexes that form and break in rhythms set by the turn. The new smoothness of the crust favors repetition rather than chaos. Outgassing still happens, but it is sifted by texture and by the quiet guidance of layers laid down or repaired at perihelion. Motion listens to chemistry in this account. Carbon dioxide declines, reducing the likelihood of ragged thrust from random vents. Carbon monoxide persists, and sometimes partners with trace metals carrying heat along the surface rather than blasting it outward. The non-gravitational terms in the orbit solution find a gentle, steady shape consistent with a body that now manages the way it absorbs and returns energy. There is no need to claim regulation beyond what texture and composition can supply. There is only the suggestion that the outer centimeters have organized themselves and that this organization favors coherent behavior over sputter. By the close of this phase, the ledger of differences is simple to write and not simple to explain away. Carbon dioxide falls where it was expected to rise. Carbon monoxide rises where it was expected to share the stage. Hints of nickel carbonyl appear and fade in a rhythm that tilts toward the rotation. Oxygen, if freed, refuses to proclaim itself. The coma stays tidy. The light remains calm. The path across the sky continues to accept prediction. Once the smallest of steady pushes is allowed, chemistry joins light and motion in pointing toward the same quiet idea. The surface after perihelion behaves as if it has been tidied, and tidiness at this scale reshapes how molecules choose to move. Rhythm gathers across instruments the way tide gathers across a bay, arriving everywhere at nearly the same time with nearly the same shape. When the post-perihelion record is folded not only by the slow hours-long rotation, but also by a shorter cadence, a second pulse appears. It repeats close to every 28 minutes, too quick to be the turn of the whole body, too slow to belong to electronic housekeeping, and it touches more than one kind of measurement. Photometry lifts by a trace at the crest. Polarization grows slightly more orderly. A narrow spectral mark strengthens and then softens, and in the radio a faint stitch of power steps up and down as if keeping time with light. The first hints feel like coincidence. A sequence from a mountain observatory shows a shallow brightening that repeats with a period near half an hour. Then a separate radio array, working on another continent, logs a run of minute modulations at the same spacing. Each group looking only at its own data files, the effect under curiosities to revisit later, the way observers learn to hold patterns lightly until they survive new nights. Weeks of overlap begin to compress those maybes into a map. Independent teams at different longitudes see the same soft rhythm. Software written by different hands folds the same period into the same result. The pulse is small, but it persists. Spectroscopy adds a delicate counterpoint. The faint lines that suggest metallic carbonyls breathe in phase with the 28-minute beat. At the crest they sharpen as if the molecules favored by heat and texture are briefly more populous or less hidden, then they thin again without drama. The carbon monoxide band itself follows the rise and fall by a smaller amount, a quiet echo to the more sensitive trace. The earlier decline in carbon dioxide does not reverse. Instead, the shorter cadence rides upon the longer change the way ripples ride a slow swell. Instruments that listen to fields and particles contribute their own modest measures. Magnetometers aboard a solar mission that happens to sweep near the object's downstream environment record a feathery undulation at about the same interval. It is not a storm and not a spike, only a low regular tilt in the background that appears when the geometry brings the probe through a sector downwind of the visitor and vanishes when the line of sight drifts away. Taken alone, it would not claim a connection. Placed beside the light and the chemistry, it begins to look like another facet of the same quiet beat. Astrometry, which usually speaks in straight lines, hears the rhythm indirectly. Residuals plotted against time show tiny correlated wiggles that average toward a minute change in path when the measurements extend over many hours. No single cycle moves the position enough to announce a shift, but the sum over a night favors a direction ever so slightly. Orbit solvers that let a gentle, constant push act upon the body already fit the post-perihelion arc better than gravity alone. If that push is not perfectly constant but arrives in small, even increments that average to steadiness, the residuals relax further. The effect is the size of a whisper, but it is consistent, a heartbeat that steers. Simple models can host such a cadence without strain. One imagines the equatorial belt heat-tempered at closest approach, acting like a thermal capacitor that fills and empties in a set rhythm determined by thickness, conductivity, and spin. As the belt warms and cools, the balance between reflection and emission could shift by a fraction, and with it the tiny force of sunlight on a smoother face would tilt slightly in a repeating way. Another model keeps a narrow vent alive at depth after the perihelion cleaning, breathing in a slow sequence as shadows slide and pressure equalizes, producing a plume so fine and so steady that it escapes detection, except as a regular touch on the motion and a regular lift in the most sensitive lines. A third picture invites the surrounding field to share the tempo. If ions within the plume respond to a local structure in the solar wind, a standing pattern could develop for a time, guiding the flow into a column whose strength grows and eases as the rotating surface presents, conceals, and presents again the entrance to the favored path. In that case, the cadence would not be exactly the rotation, but a beat between the spin and the slow turn of field geometry around the body. The measured interval sits comfortably on such a shelf, a subdivision of hours, that would drift only slowly as angles change. The restraint of the phenomenon is as telling as its presence. Nothing in the 28-minute rhythm shouts. There is no flash, no burst, no plume that thickens into a fan. The coma remains tidy. The light curve stays small. The polarization inversion holds its sign without flipping back. Chemistry favors rebalancing over eruption. The beat simply rides under all of it, patient, and even as if the surface and near surface are exchanging energy and material along a path that has learned its own timing. The body looks less like a furnace and more like a metronome warmed by the sun. Instrument teams test for the many ways a cadence can grow from their own machines. Wheels and pumps can hum in intervals, software can sample in patterns, thermal controllers can cycle. Logs are checked and cross-checked. Observatories separated by oceans and by design philosophies see the same interval in the same windows, and those windows follow the target, not the bench. The radio arrays that report the whisper of power keep their calibrators near at hand and watch them remain flat. The small rise and fall belongs to the sky. Over days, the practical consequence of the beat becomes clearer. The integrated effect of many small equal touches is a very slight change in velocity, a layered addition to the steady non-gravitational push already written into the orbit. The magnitude remains gentle enough to sit within comfort for prediction, yet precise enough that the updated solution carries the rhythm's signature as a reduction in scatter. The path on the sky is easier to forecast because the object appears to be helping by moving in a way that is not only lawful but also regular. The language in notes remains careful. Words like oscillator and cycle hover at the edge of drafts and then settle into safer terms, such as modulation and cadence. The narrative does not need to argue for control to admit regularity. It can simply note that a skin smoothed by heat, a vent tidied by stress, or a plume guided by a patient field can all adopt habits that last for a span and then fade. What matters is that during this span, the 28-minute rhythm links light radiochemistry and motion into a single low-amplitude behavior that treats energy as something to be paced, not spent. As the interval continues to appear, and then on some nights to rest, the sense of a system grows. Not a machine, but a set of coupled processes that answer to the sun, together a belt that redistributes warmth, a surface that reflects with new coherence, a channel that breathes in fine measure, a column that holds a line when guidance is kind. The cadence lays a soft hand on trajectory and an even softer one on brightness, and in doing so it offers a way to imagine the object as more than a lump dissolving under light. It behaves like a body that can keep time. Where that timekeeping leads next belongs to the field around it, where the wind of charged particles sometimes learns to part and sometimes learns to sing. Silence takes a shape. In the hours after the plume holds its line and the 28-minute cadence settles into the record instruments that listen to the sun's wind, begin to find an outline not of light, but of less. The Parker Solar Probe drifts through a region predicted to lie downstream of Atlas III's path and notes that the count of charged particles falls away not as a noisy dip, but as a clean trough, a hollow in the stream. The fall is narrow in space and brief in time, and yet the boundary is tidy as if a skin had been drawn around an absence. Later, when the solar orbiter crosses a different slice of the same projected wake, the pattern repeats with the same restraint. Two separate traverses taken under different angles and hours apart sketch the same soft cavity, moving with the object rather than with the weather. The maps built from these passes resemble medical images of a heartbeat seen in cross-section. The solar wind flows around an emptiness that does not belong to turbulence or to chance. The cavity's edge brightens in data where charged particles are redirected, then dims within where counts thin toward quiet. The shape is not a sphere and not a ragged void. It opens slightly in the direction away from the sun like a bow wave, then narrows again as the stream downstream reclaims its ordinary texture. When the object turns, the cavity turns with it, keeping alignment to the new vector as the orbit solution updates with the small, steady, non-gravitational terms already in play. Such hollows have names in other settings. Planets with strong fields carve magnetospheres that part the wind with force. Comets rich in gas can inflate comae that push the stream with sheer density. Atlas III is neither a world nor a storm. The cavity here is thin and disciplined, more like a sheath than a bubble. Its thickness, measured by the time a probe spends inside it, its strength read in the way particle counts bend rather than crash. The simplest picture draws a skin of altered space around the visitor, a region where charges are discouraged, where flow lines curve aside, and where the airless discipline of the heliosphere yields very locally to an order set by the small body's presence. Oscillations ride the boundary like ripples on a drumhead. Magnetometers register standing waves that hum at harmonics of the object's slow rotation, with a gentle emphasis near the same 28-minute beat that has appeared in light and chemistry. The waves are small, easy to lose in haste, but they repeat when geometry brings a probe through the sheath under similar angles. Folded against time, their crests align with the minor lifts in the nickel-bearing spectral hints and the soft steps in radio power. It is as though the cavity breathes with the rest of the system expanding and relaxing by a few careful measures while keeping its outline intact. The environment beyond the sheath offers a control. Outside, the wind behaves as forecast, lively but ordinary, with variations set by the sun's broad weather. Inside, the noise floor calms. Fluctuations shrink. Temperature gradients flatten across the span of a transit. The effect is not total, only convincing, as if the visitor has made a small promise to itself to keep its immediate surroundings quiet. When the solar wind burps a minor disturbance, the sheath wrinkles and then restores its boundary, flexing rather than breaking. The image that suggests itself is a thin film stretched on a frame, finding a new equilibrium as pressure changes, then resuming its measured stillness. Conservative explanations ask little beyond materials and fields. A surface that has grown smoother and more reflective can also grow more charged in sunlight, building a patchy potential that shapes incoming particles for a time. A fine ion-rich plume, when present, can seed a local field geometry that guides charges aside the way a small island splits a river's thin debris. The perihelion belt, now a tidier equator, can redistribute currents across longitudes so that the sheath steadies rather than flutters. None of this claims a new force. It only admits that near a rotating lit surface, the familiar interactions of charge flow and texture can take on structure when conditions are delicate and the timing is kind. The maps change slowly over days, and that slowness is part of the proof. If the cavity were only a wake thrown off by a transient jet, its form would smear and drift with every small shift in outgassing. If it were only a gap carved by random low-density parcels in the wind, its edges would lack memory. Instead, the sheath holds its alignment to the outbound vector, even as the predicted path slides by fractions to accommodate the gentle pushes seen in astrometry. The boundary seems to prefer a fixed standoff distance from the nucleus, receding slightly when the wind grows rougher, advancing when it softens in a manner that suggests feedback rather than inertia. A directional detail emerges when the observations are stacked, The cavity is not symmetric about the object, it opens more widely away from the sun, as if shaping a corridor into which the visitor travels. Along that corridor, fluctuations are faintest and particle counts lowest, a quiet lane that lengthens and shortens with the cadence already measured elsewhere. The corridor is not a tunnel, it is a bias, a preference in how the sheath chooses to make space. Put in simple terms, the object seems to carry a calm with it, and also to point that calm where it is going. Tests for instrumental illusion multiply because mapping a negative is harder than mapping a glow. Particle counters are checked against their own housekeeping cycles. Backgrounds measured before and after the passes are subtracted to guard against slow drift. The same cavities are found when instruments are run with different gains, when attitude changes shift field angles, and when analysis is performed by teams who do not share code. Cross-checks with radio scintillation, which can feel the roughness of plasma along a line of sight, show a matching softening when the line crosses the corridor. In the language of careful notes, the feature is robust. The sheath's presence ties threads together without forcing them into one rope. A smoother skin, a straight plume, a polarization that favors direction, a chemistry that chooses steadiness, and a cadence that keeps time with a slow internal rhythm can all contribute to a region where charged particles are gently kept at bay. In such a region, the tiniest forces act with less noise. Radiation pressure meets a more coherently reflecting face. Any fine vent, when active, expels into a path of least turbulence. The consequence is a motion that accepts prediction with unusual grace once the smallest regular terms are honored. What the sheath does not do is roar. No storm announces it. No lightning crackles along its edge. It simply remakes a few thousand kilometers of near space into a softer version of the heliosphere and carries that softness along like a boat's laminar wake on a broad lake. The image is a metaphor and remains safely so. The data only insist that a thin directional quiet exists and that it moves with Atlas III as surely as its shadow moves with it. The next hours in the record will test how far such quiet can be stretched. A corridor can widen, a sheath can deepen, or both can collapse back into the wind as the object cools and the sun's press relaxes. For now, the outline holds carved not by force, but by exclusion, a silence drawn in fire and carried through it. The maps add another landmark to the growing chart, a calm that travels a shape made of less, and a space that seems to be prepared ahead of motion rather than left behind it. The gap does not look like failure, it looks like stillness. 43 minutes begin and end with clocks that agree down to small tolerances, and in between the streams that usually waver with life do not waver at all. The solar and heliospheric observatory continues to time its cadence. The solar orbiter and the Parker solar probe keep their housekeeping steady ground arrays, hold their integrations, and every ledger that should show a busy sky instead shows a flat line. No burst of noise declares overload. No ragged packets hint at compression on the edge. The interval is immaculate, a quiet so clean that it reads less like a loss of sight and more like the temporary absence of anything to see. Engineers try the ordinary keys first. They test for synchronized software behavior, for shared thresholds that might discard frames in concert, for clocks that could slip by the same small fraction and line up emptiness by accident. They audit pointing gain compression and the logic that decides whether a bright image is salvageable or must be dropped. The systems remain prosaic. Telemetry outside the region of interest flows without interruption. Calibrators read as expected. The sun watched in other directions keeps its usual weather. The quiet occupies only the coordinates that belong to Atlas III and only the span that brackets the cadence that came before. A trace arrives from an unexpected corner and then goes still as well. The deep space trackers, which keep their own council record, faint, repeating echoes in the background just before the quiet takes hold. The spacing between them is near 11 seconds, too orderly to be wind and too soft to be announcement. When the silence begins, even those whispers fade. The story holds steady for the length of the interval and then resumes with the same clocks that opened it, as if a curtain had been drawn and then lifted on cue. Ultraviolet instruments add a single pinprick to the otherwise blank page. Just before the stillness, a narrow emission line flashes from the direction of the object, sharply defined and lasting less than 2 seconds. The wavelength sits in a region where sunlight and dust rarely make such neat features. It comes and goes so quickly that only careful stacking of frames confirms it. Then the gap opens and the record returns to calm. The line does not repeat in the first minutes after the quiet ends. It remains an isolated note, written at the edge of silence. When the streams come back, motion has changed by a hair. The orbit solution improves if a small brief deceleration is allowed during the interval. The magnitude is modest, counted in tens of meters per second rather than hundreds, and the direction is consistent with the gentle outbound path already traced in the nights before. The vector tilts by a fraction that is easy to miss in a casual overlay and stubborn in a patient fit. Residuals settle when the deceleration is included. They widen again if the interval is treated as uneventful. The change is small enough to keep prediction comfortable and large enough to keep attention awake. Downstream of the new path, the wind holds a faint signature that behaves like wake rather than weather. The Parker Solar Probe passes through a thread of lower particle density aligned to the updated vector, a curve that looks like a contrail drawn through plasma. The counts thin, then thicken, then thin again, in a sequence that echoes the same slow cadence logged elsewhere. Within the thread, narrow hints of metallic ions rise above background by only a little, but they do so with a geometry that remembers the corridor mapped earlier, the sheath that preferred the outbound direction and kept its own standoff distance. Radio observatories that devoted their attention to the coordinates during the quiet report, nothing to hear, that absence matters. In ordinary interference, static climbs when instruments are stressed. Here noise drops. The line is straight, not because the instruments have forgotten how to feel, but because the region they sample has been made even like a lake that has briefly lost its ripples. The phrase used in careful notes is temporary suppression rather than outage, a way to admit that the devices worked and the sky to which they listened did not answer. Conservative pictures step forward to share the weight. One holds that the sheath already mapped in plasma widened, suddenly smoothing variations across a span large enough to swallow the diagnostic contrast that instruments require. In this view, the quiet is containment, a brief expansion of order that erases texture. Another suggests that the surface warmed and tidied crossed a threshold where reflection and emission arrange themselves to minimize the signatures that habitually betray small bodies near the sun. In such a regime, the object would still be there, still turning, still responding to light, but so efficiently that the usual fingerprints fade for a time below detection. There is room, too, for a simple mechanical sequence. A vent that had breathed in clean measure could have closed with unusual neatness. A belt that had cycled could have completed a phase and paused. The corridor in plasma could have grown quiet while the field around it reset its balance. The deceleration that survives the fit would then be the integrated effect of tiny acts performed within a span too calm to advertise them as they happened. The ultraviolet line at the edge of the interval would be a preface, not a proclamation, the last glint from a process that then moved behind a softer curtain. What follows the gap is as telling as what fills it. The rotation remains steady. The inverted polarization holds. The chemistry continues to favor carbon monoxide over carbon dioxide, with the faint metallic signatures still rising and falling in a patient rhythm. The sheath shrinks back toward its earlier shape and keeps traveling with the object directional and thin. The orbit, once updated, resumes its comfortable habit of matching prediction to position with small systematic terms that are easy to carry. Nothing breaks and nothing hurries. The quiet leaves no turbulence behind it. So the 43 minutes take their place with the missing frame, the thermal belt, the straight plume, the inverted light, the rebalanced gases, and the 28-minute heartbeat as another landmark that requires no declaration to hold meaning. The pattern they sketch is not one of drama, but of order. A small body near the sun rearranges its skin, paces its energy, shapes a corridor of calm, and for a span curates its own appearance so completely that instruments still healthy and still attentive record nothing but stillness. When the interval ends, the object is a touch slower and a touch farther along a slightly different line, and the sky resumes its gentle noise. The map gains another quiet place that future readers of the record will circle not as proof, but as a point to which later changes can be anchored. A measured pause that behaves in the mathematics, if not in the light, like purpose wearing the shape of nothing. The second trace enters the record as a pale companion that refuses to behave like a shard. Hours after the long, quiet, deep integrations from wide-field cameras show a faint point walking the same line as Atlas III, but lagging by a consistent distance measured in tens of thousands of kilometers. At first, the extra dot is folded into the vocabulary of fragmentation, a common fate for small bodies that have tasted heat. Yet the behaviors that ordinarily announce a fragment ragged, brightening, chaotic spin a dust veil untidily shed do not appear. The newcomer holds steady. Its brightness stays even. No plume curls from its position. It is simply there, small, cold, and punctual. Observatories at different longitudes recover the companion and measure the spacing again. The number remains the same from night to night within modest uncertainty, as though an invisible tether keeps time between them. Radio techniques that sense motion through tiny Doppler shifts add a soft detail. The smaller trace rotates, but with a smoothness that suggests habit rather than accident. The period is not the same as the larger body's hours-long turn, yet the phase between them drifts slowly as if two metronomes in the same room are listening enough to one another to settle into near agreement. Where light is faint, fields sometimes speak more clearly. Magnetometers aboard a solar mission find that the breath-like undulation already linked to Atlas III acquires a second voice separated by a small constant delay. A slight rise at the main object is followed by an answering lift at the companion a couple of heartbeats later. The exchange repeats for as long as geometry keeps both within sensitive range. The amplitude is tiny, the timing gentle, and the pattern remarkably polite, not a shout across space, but the quiet call and response of systems that share a medium and a pace. Astrometry folds the companion into its careful plots. Residuals from the tandem motion show that the offset between them decreases at a rate so small it could be missed in a single afternoon, and so steady it cannot be ignored over many. The separation closes by a handful of kilometers each hour, which is to say by almost nothing at any given minute, and by inevitability when added across a day. Orbit solvers that allow the main body's modest non-gravitational terms now extend those terms to the companion and find that the two together behave more like a pair than like a body and an accident. Each small correction in the model improves both fits. Skeptical pictures are given their turn as they should be. Could the trailing point be a reflection of the brighter head, an artifact of optics rotating the field and changing filters would move a ghost? This one stays where the sky says it should. Could it be an unrelated object that happens to pass nearby? Its motion matches the line and pace of the primary too precisely for coincidence to survive more than an evening. Could the smaller trace be a cloud rather than a kernel? The tight, nearly stellar profile endures even when seeing degrades, and no halo widens around it to betray dispersed dust. The companion continues to behave like a thing rather than a blur. As the spacing narrows, brief sequences catch a small choreography. The companion makes tiny cross-track corrections that mirror after a short wait the main body's minute shifts, as if comparing notes and matching the line. Along the corridor of calm in the solar wind, particle counts fall a little more whenever the two align, then lift again when the lesser trace drifts aside. The sheath that travels with the pair seems to widen by a fraction for a while, as though the quiet can hold more than one passenger without tearing. Nothing here forces a grand mechanism. The picture can sit easily upon charge reflection and a path through a gentle field. Hours pass into a night when the closure becomes contact. No flare announces the meeting. The light from the combined position rises by a small, precise percentage, the exact amount that adding the lesser to the greater would supply if neither shattered. Radar reflections, weak as they must be at such distance and size, sharpen into a single return. In the magnetometer's ledger, a narrow pulse taps once a clean crest that lasts no longer than a tenth of a second, and then the background resumes its steady undulation. The sheath around the path wrinkles slightly and then smooths. No debris fans outward, no plume blooms. The point that had been two becomes one. What follows is restraint. The new single body keeps the calm rotation it learned before perihelion, and the 28-minute beat continues under the light curve as if the slow oscillator has welcomed a missing weight back into its rhythm. Spectroscopy sees the same rebalanced chemistry, with carbon monoxide still favored over carbon dioxide, and the faint metallic hints still breathing in time. The polarization inversion holds its sign. The corridor through plasma remains directional and thin. The orbit solution, updated with the final small shift of velocity at contact, returns to its comfortable habit of predicting position with little scatter once the tiny steady terms are allowed. There is room in this quiet merge for small ordinary mechanisms to do the work. A fragment that did not tumble could have separated earlier, when the perihelion belt shed its skin, drifted behind in a lane protected by the sheath, and then slowed by a touch of radiation pressure that the smoother main surface resisted, better eased back into the shallow gravitational well of the larger piece. Fine charges shared across their faces could have helped align and settle the pair without sparks. A deep vent that briefly guided flow might have carved a pressure field that favored reunion along the corridor's axis. None of these require design. All of them require patience, which the record supplies. The alternative reading that the two behaved as parts that remembered each other does not need to be argued to be felt. It is present in the steadiness of the spacing during pursuit, in the small echo between their field signatures, in the exactness of the final light increase, and in the absence of any messy aftermath. The notes that file the night keep their verbs plain. They say approached, converged, and merged, each with times and uncertainties. They add that no fragment was seen to escape. They close with the reassurance that prediction remains reliable and that the next windows for observation are unchanged. In a narrative written by instruments that prefer order, the reunion reads as another landmark added to the chart with a soft hand. After a passage defined by small regular acts, smoothing a skin, pacing heat, shaping a corridor, pausing into stillness, Atlas 3 divides without spectacle, and then joins without harm. The ledger records a return to one with barely more brightness and barely less speed, and then a deepening of quiet, as if a cycle has completed. The story does not end here, it rarely does in astronomy. The next hours will carry a new brief feature in radio that points outward into the larger dark, and the map will add that note to the growing list of gentle signatures. For now, the merge point drifts on, even composed and easy to find wherever the equations place it. The pulse arrives after reunion with the gentleness of a pebble placed on a table. Arrays that listen for deep spacecraft keep an unfussy watch on the region and find for a span shorter than 5 seconds a narrow tone centered near 8.41 gigahertz. It is neither loud nor ragged. It rises cleanly, holds a flat top that is modest rather than sharp, and then falls as if set down rather than dropped. Pointing solutions from dishes separated by oceans trace the source to the same small patch of sky that belongs to Atlas 3, and the tiny Doppler drift of the line matches the predicted motion of a body gliding outward. The feature is beam-like in the old radio sense. When antennas nod away from the target, the power falls quickly. When they return, it sits waiting. The signature is built of 2 parts, a carrier that stays steady at its high frequency, and riding upon it a faint tremor at 440 Hz that appears as symmetrical sidebands in spectra taken with enough resolution to show them. The modulation is shallow, like the ghost of a hum heard through a wall. It is not encoded with information that can be read. It is simply a rhythm, the same concert pitch that had brushed the end of the long, quiet hours earlier, now placed atop a microwave note and sent outward along the outbound vector rather than back into the inner sky. Conservatism asks first whether the sound could belong to Earth. Schedules for satellites are pulled, and the directions of their side lobes and reflections are plotted against the hour. The lines fail to align. Receivers change polarization and keep the detection. Arrays switch to off targets, and the line vanishes, return, and the line returns. A station on another continent records the same 5-second feature with the same slow drift. Most decisive is the view from space. A solar mission with a small radio package happens to look through the same region and finds the tone at the same moment, with no atmosphere to carry terrestrial interference to its dish. The checks do not prove origin. They remove simpler confusions. The field around the object reacts as if tapped rather than struck. Magnetometers that had been tracing the gentle undulations of the sheath register a single clean crest that lasts about 1/10 of a second just as the radio tone ends, then return to their background breathing. Particle counters do not jump. The corridor through the wind does not tear. The quiet lane mapped in earlier passes holds, and within it, the counts thin a little more for a minute, then ease back the way a lake's skin settles after a skipped stone. Light answers with restraint. Photometry taken within minutes of the event shows a small decline in reflected brightness, only a few percent consistent across filters that had recently favored a smoother, more reflective skin. Polarization keeps its inverted sign but lowers its degree by a measurable hair, as if the face has dulled slightly, or as if dust at the edge of the coma has grown even rarer and left fewer planes to reinforce a shared orientation. Spectroscopy adds a parallel note: carbon monoxide remains favored over carbon dioxide, and the faint metallic hints tied to nickel-bound molecules continue to breathe in their slow way, but the amplitude of their undulation shrinks for an hour before recovering to the familiar patient rhythm. Astrometry folds the moment into motion with a line too small to feel but clear enough to fit. A slight deceleration during the minute centered on the radio pulse reduces residuals more than randomness would, and it leans along the same axis that the non-gravitational terms have preferred since reappearance, a tiny answer pointing opposite the path of travel. The magnitude is counted in tens of meters per second, again shy of anything a storm would supply, again sufficient to move the future track by millions of kilometers given enough time, again gentle enough that prediction remains comfortable once the term is written into the table. Interpretations that live safely on the natural shelf multiply without competing. One proposes that a brief coherent scattering phenomenon encouraged by the newly tidied skin and a transient alignment of facets created a microwave flash by reflecting thermal noise in a narrow band, the way a mirror glints in sunlight for a heartbeat. In that picture, the 440 Hz tremor would be a residue of the longer system rhythm, riding through a transient optical path, an imprint rather than a code. Another sees a tiny discharge along the sheath's boundary, a redistribution of surface charge across a smoother crust that rang the field for a moment at a high frequency while the slow oscillator hummed beneath. A third keeps the analogy to chemistry alive, allowing that a cycle in which carbon monoxide forms and falls apart across metal-rich patches could at completion briefly alter the dielectric properties of the outermost layer enough to focus and then unfocus a microwave glint. All three accounts are compatible with the restraint of the environment. None requires an outburst of gas or a surge of particles. All rely on structure that the record already admits: a smoother surface, a belt that shares heat, a sheath that discourages turbulence, and a cadence that couples light, chemistry, and field. The beam-like behavior follows naturally when the corridor is already directional. The sharpness of the start and stop follows when the processes involved have learned to complete phases cleanly since perihelion. Instrument teams stress their systems once more. They inject artificial tones at the front ends and push gains to edges to test for intermodulation. They examine time tagging for offsets that could align random noise into a transient that seems coherent. They swap processing pipelines and find the same 5-second note in independent reductions. They stack off target data and find only noise. The page in each log where the checks are listed looks longer than the page where the detection is described, which is how careful work should read when a quiet anomaly refuses to be blamed on the bench. After the pulse, the system coasts into a deeper soft. The 28-minute heartbeat remains, but loses contrast for a day, then returns. The sheath narrows by a small steady fraction and continues to travel as a calm lane. The inverted polarization holds with its reduced degree. The brightness sits a little lower and steadier. The non-gravitational terms in the orbit solution keep their small values and their stable direction. In other words, the note is followed not by echo upon echo, but by a mild dimming that feels like completion rather than exhaustion. The ledger of landmarks now includes a sound. Not a message, only a phenomenon, a narrow high-frequency tone briefly carrying a familiar low tremor beamed along the path that leads away from the sun, placed between reunion and deeper quiet. It does not overturn the story built so far. It adds an accent. The same object that learned to smooth its skin, to pace its heat, to hold a straight plume, to shape a corridor, and to pause into immaculate stillness, now adds one more measured act and then dims as if a sequence has reached its last step for this pass. The maps keep their modest confidence. The sky resumes its ordinary noise, and the point that had brightened and disciplined itself begins gently to let distance do what it always does. Quiet becomes a phase rather than a moment. In the days after the narrow radio note and the small deceleration, Atlas III settles into steadiness that is measurable across many instruments at once. Brightness flattens into a gentle plateau that declines only with distance, not with surprise. The inverted polarization keeps its sign while its degree eases downward by a fraction, like a surface that remains coherent yet chooses less emphasis. The coma stays compact. No fresh fans appear and no stray fragments trouble the photometry. The orbit solution, now carrying small, regular, non-gravitational terms as standard, continues to predict each night's position with the comfort of routine. Thermal bands speak of evenness. The belt that once brightened at perihelion no longer announces itself as a feature. Instead, the skin radiates as if heat is being shared laterally with quiet efficiency. Minute undulations remain at the familiar cadence near 28 minutes, but they ride so lightly on the curve that integration is needed to hear them. Spectra keep the same ordering as before: carbon monoxide, modestly favored; carbon dioxide, modestly subdued, and those faint metallic hints appearing and softening with patience rather than with drama. If chemistry once beat like a small drum, it now ticks like a watch. Rotation behaves as if it is being respected. The period holds within a narrow band close to 3 hours, drifting only by slivers that accumulate slowly and then are given back. No sudden spin-up arrives and no tumbling begins. The light curves' small repeating folds map longitudes that have not forgotten their habits. When fits are made that allow a tiny precession, residuals lean toward acceptance, as though the axis itself nods by a hair and then returns a motion so modest that it serves more as a test of the reduction than as a claim about the body. The overall impression is calibration rather than change. Motion through the wind answers with the same restraint. The sheath that earlier discouraged charged particles continues to travel with the object thinner now by a measured fraction, yet still directional, still opening more widely away from the sun, still keeping a preferred standoff distance that flexes only as much as the weather requires. Along the corridor, radio scintillation smooths and roughens in step with the gentle cadence, as though the lane inhales and exhales a little without abandoning its outline. Crossing probes record that the floor of particle counts rises slightly week by week, but the signature remains unmistakable, a quiet carried forward. Field instruments folded against time find new delicacy in the ripples they trace. The standing waves that hum on the sheath's boundary sometimes split into a near doublet. 2 close notes separated by a barely measurable delay, the first crest leading the second by less than a second. The pattern appears only when geometry is kind and vanishes, when angles turn unfavorably, yet when present it repeats with a regularity that invites patient speculation. The safest shelf holds explanations that need only structure and environment, a surface layer that cools in 2 coupled loops, a pair of shallow vents that breathe out of phase beneath the resolution of imaging, a field that answers to the spin and to the corridor's direction, at once dividing its small tension into 2 nearly merged beats. Thermal mapping, limited by distance and glare, nonetheless offers one more hint. On some nights, the faintest warmth concentrates at 2 opposed latitudes that mirror one another across the equator. The peaks advance with rotation like twin glints, dim enough to require stacking, steady enough to survive it. Such symmetry can live in simple places. Conduction along a shallow, denser stratum could carry heat around the waist and deliver it to 2 persistent shoulders. Albedo patterns baked in by perihelion could maintain the same rhythm until distance softens them away. The observation does not insist on compartments, it only nods toward balance. When modelers fit all of this at once, light polarization, chemistry, sheath cadence, they sometimes borrow an analogy from spacecraft to help organize their thoughts. They imagine a mass within the body that need only shift by a small amount to alter how the shell responds to sunlight and to the wind, a reaction wheel, by metaphor, not by claim, that trades tiny changes in interior arrangement for even tinier changes outside. Computer experiments show that such an internal give and take can reproduce the relaxed precession, the persistent corridor, and the narrow, regular, non-gravitational terms without demanding large outgassing or thick dust. The language in the notes remains careful. It is not a declaration of mechanism, only a framework in which modest coupled processes can keep time together. Outbound distance adds its own discipline. As sunlight weakens, contrasts fade kindly. The 28-minute beat loses amplitude by degrees, yet keeps phase like a pendulum that swings shorter arcs without losing count. The metallic carbonyl hints so tentative to begin with become intermittent and then rare until they appear only when long integrations happen to stack upon a favorable turn. Carbon monoxide's advantage over carbon dioxide narrows but does not invert. The inverted polarization remains, then shallows, then approaches the ordinary curve without quite crossing it. Each of these softenings feels less like decay than like a system releasing tension as the star's grip loosens. Astrometry registers the cumulative effect of all this gentleness. Over weeks, the outbound vector bends by a fraction upon fractions, always in the same sense, always small and always welcomed by the fit when added as a steady low term. The corridor in plasma points along the same slight curvature, a guide drawn ahead of the motion rather than a wake left behind. If a planner were sketching the path, the line would look like a hand guiding a bead along a wire that arcs only a little and never kinks. Prediction remains friendly. Extrapolations prefer smoothness. In the background of the heliosphere, the echo of what has happened does not vanish at once. Far from the object along the lane, it has already traveled wide baselines, and radio sometimes find a faint low frequency weaving in the noise of the solar wind. Folded with care, the thread leans toward the same rate that the sheath liked to hum a few beats every second, barely there. Interesting because it appears only where the path has been and not where it has not. The feature is too thin to serve as more than a suggestion, yet it adds to the sense that this passage leaves memory in the medium, a residue of timing written into moving air. By the time the object grows faint enough to sit at the edge of comfortable reach, the map of its behavior reads like a sequence written in small letters. A missing frame that coincided with perihelion, a belt of heat that brightened and cooled as one, a straight plume that held its aim and stopped cleanly, a polarization that turned and then held, a chemistry that rebalanced with quiet preference, a cadence that kept time across instruments, a sheath that shaped a lane of less, a long silence that behaved like containment, a reunion that produced no mess, a narrow radio note aimed outward, and then this long, slow rest, in which all the earlier pieces eased into equilibrium. The next and last section will carry that sequence outward beyond easy sight, where pattern becomes memory and prediction becomes patience, and where questions are left to drift beside a path that now glows only in careful sums. Distance takes the lead and begins to do what distance always does. Atlas III recedes into a portion of sky where signal yields to some, where a point that once required only attention now requires patience as well. The last nights that hold it cleanly are set by geometry more than by will. Phase angles lengthen, air grows less helpful, and the thin quiet the object carries with it becomes harder to distinguish from the broader quiet of the heliosphere itself. Observatories that have followed since discovery plan their handoffs as they did at conjunction, but this time the trade is not from one instrument to the next, it is from watching to waiting. Brightness behaves like a long exhale. The curve declines with distance as the models predict, without spikes, without sudden hollows, and with a steadiness that lets integration times stretch to match. Polarization relaxes toward ordinary values, the inverted sign holding a little longer than expected, and then drifting toward neutral without quite crossing back during the last comfortable windows. Spectra that once carried modest differences flatten. Carbon monoxide still wins by a small margin. Carbon dioxide still sits low by a small margin, and the faint metallic hints fall below reach except on nights when time, weather, and angle happen to stack their favors. Field measurements find their amplitudes thinning by the same rule. The sheath that traveled with the body narrows and then becomes a preference rather than a structure, a tendency for counts to soften along the outbound vector rather than a corridor with a readable edge. Standing waves on its boundary fade from tones into texture. The 28-minute heartbeat, once patient and clear under careful folding, becomes a suggestion, then a guess, then a habit of looking that yields only when the sums can no longer distinguish repetition from desire. Instruments do not lose discipline, they simply reach the horizon of what distance will reveal. Astrometry continues to be the craft that ends last. Even when features soften and lines flatten, position can still be measured, and the small, steady, non-gravitational terms that have improved every fit since reappearance continue to earn their place in the tables. The outbound path bends by the same fraction upon fraction seen earlier, always in the same sense, always small, always welcomed by the fit. Plotted far ahead, the differences add up to changes measured in millions of kilometers, which is to say, little and much at once. The Minor Planet Center posts new solutions at a tempo that lengthens with time. The International Asteroid Warning Network relays the updates. The Planetary Defense Coordination Office and the European Space Agency's Centers for Near-Earth Monitoring stamp their bulletins with calm phrases that mathematics deserves prediction remains nominal. Uncertainties contract and then level. Ephemerides will next be revised when new astrometry is acquired. Comparisons to earlier visitors help set this passage within its quiet scale. The first known interstellar body announced itself by brightness and odd motion. This one announces itself by order, by restraint, and by a sequence of small, repeatable acts that sit comfortably on shelves built from reflection, charge, chemistry, and field. The record does not ask for invention, though it leaves room for imagination. It shows a skin smoothed by heat, a belt that brightened and cooled together, a plume that held a straight line and then ended cleanly, a light that remembered its surface differently, a chemistry that chose balance over bloom, a heartbeat that kept slow time across bands, a sheath that shaped a lane of less, a long quiet that behaved like containment, a reunion that left no mess, a narrow radio note that aimed outward and then ceased, and finally this long easing in which everything that had been paced continues to be paced, while power declines with distance. The double language that has accompanied the story stays with it into the dark. A conservative reading shaped by decades of experience with small bodies under light continues to carry the day in public notes, non-gravitational acceleration consistent with surface evolution, polarization consistent with coherent backscatter on a newly smooth crust, transient collimated outflow consistent with a deep fracture, temporary suppression of environmental variance consistent with a broadened plasma sheath. A more speculative reading, spoken softly in workshops and late offices, points to the same lines and hears the same rhythm, and calls the coherence itself the finding. Neither reading closes the other. Both are ways to honor the data with the fewest assumptions. Archiving begins to share the load with observing. Raw frames reduce tables, pointing logs, and the small essays that accompany them move into repositories that are designed to keep things both safe and reachable. The European Southern Observatory and national observatories tidy their mirrors and their metadata with equal care. Teams annotate their reductions with the humility that time rewards parameters fixed and parameters allowed, steps tried and steps abandoned, cautions, caveats, and places to begin again when a future instrument looks back with new reach. Spacecraft teams package their traverses through the sheath with the same attention. The Parker Solar Probe, the Solar Orbiter, and the Solar and Heliospheric Observatory leave behind not only plots, but also the housekeeping that proves those plots belong to sky and not to bench. Beyond those ledgers, the heliosphere keeps a faint memory of the passage. Along parts of the lane, the object once took very long baselines in radio, find a thread in the noise that appears only where the wind has already been shaped. Folded with kindness, the thread leans toward a few beats each second, a suggestion of the hum that once rode the sheath. It is not strong enough to claim broadcast, only strong enough to argue for imprint a rhythm written into moving air by a traveler that preferred order to display. Perhaps the thread lasts for weeks and then becomes the background itself. Perhaps it persists until a storm forgets it. Even the choice between those perhaps belongs to future passes of the same instruments across the same corridors of sky. Atlas III grows harder to hold and easier to imagine. The last nights of comfortable measurement bring no change in personality. The point holds its poise, accepts every forecast, once the small terms are honored, and leaves on the same line it carved for itself since the first missing frame. The map it leaves behind is not dotted with hazard signs or exclamation points. It is marked instead by landmarks that read like titles of quiet chapters. They are enough to sustain hypotheses, to shape models, and to invite the same rhythm of work that produced them: watch, measure, compare, fit, revise, and wait. Waiting is not emptiness in this trade. It is a way to give time to patterns that declare themselves slowly. If the object never returns, the record will be complete, as it is an account of a small visitor that chose order in a place where disorder is common. If it does return in some distant cycle, perhaps along a mirrored path decades from now, the ledgers will be ready to welcome it with better clocks and longer eyes. In either case, the story ends in the appropriate tense for astronomy present, going on motion continuing, inquiry unhurried. The sun keeps speaking in light and air, the instruments keep writing in their careful hands. Atlas III keeps moving outward, carrying its quiet with it, leaving its quiet behind, it becoming not a spectacle but a standard against which future strangeness can be read.